Thank you. And yeah, we very often get confused with the Livermore National Lab. They're very different. Just 1 hour away, I know, but still very different. So I'm here to talk about heterogeneous integration for HPC from a national lab standpoint. So I'm George from Berkeley. A lot of the material here was prepared by John Shelf, so you can thank him for that, for what's about to follow. So you've probably seen some version of this graph at some point. This comes from the top 500. And the solid lines are measured improvements in systems in top 500. The dotted lines are just projections. The top line is sort of the sum of the performance of the top 500 systems. The blue line that's in the middle is the top system. And the bottom line is the number 500. What's important to note in this graph is that traditionally we've been enjoying about 1,000x improvement every 10 years. And that has scaled down according to our projections by 10 to 100x. So this sort of gave the rise to specialization, or okay, what we can do to keep our performance scaling going up in the next decade. Turns out nature is actually pretty good at specialization. We're not the first ones to go down that path. We've started from like a few powerful creatures to many small ones, just as a way to survival. But then also notice that other species have specialized to optimize what's best for them. And that's sort of, we're going down that path. The companies, the strategies we're talking about here are very similar. And we've seen this. We've seen this in technology. Google TPU was a very, not a very early example, but one of the early deployments in an actual system. So that's in the data center realm. And then we have the specialized IP in the Apple chips. This graph is a little old, but the trend continues, actually increasing. A key observation, though, is that the markets that drove these specializations are big markets. So the green bars are basically the 5 companies that are over $1 trillion. You can find more information in that paper that we have this link for. Very interesting read. And then they're very able to drive specialization. They have the capability, the financial capability to do so. And then we have their Asian counterparts just to the left. And then we have the traditional computing companies, about $1 trillion aggregate, and they also have capability to drive some specialization. But where is HPC? Where is open science HPC like we do in national labs here? Doing this specialization takes a lot of investment, a lot of financial investment that not everybody can afford. There are many communities that have enjoyed the general purpose performance advancements, but if we're talking about specialization, not everybody can drive that. So HPC has become a little too small to attack the city of specialization. And with the opportunity here is that, well, we can shift the economic model that HPC can use to be part of specialization. There is a marketplace forming with open chiplets, licensable IP. This is something that we can base on as well. We can use as a basis, rather, to generate specialized IP for HPC applications, open science, and that will make it easier. So we won't have to start from scratch. We'll just start from an open source baseline and either use it or just change it. It's a smaller incremental cost. So we can move to a model where if there's a big enough market, we can use licensable IP. Otherwise, we'll just use open source IP and based on that and develop it. Then we can also partner with chip vendors. Chiplets are a big help in this because they're a great way to interoperate all these different IPs developed by different companies for different or open source IPs by different vendors, as long as we have an interoperable way to do so, of course. But we can have reusable blocks, we can have commercial IP, we can have all that in the same chiplet and have a way to communicate between the two. So I think this is a very promising path forward for developing specialized hardware for HPC. And this is already happening. So there's the ODSA project. I had to practice saying that acronym a few times, but it's the ODSA project. It has many of the components that we're looking for here. It defines interfaces between these blocks. Obviously, that's very important. It gives some reference designs that we can use to develop, to specialize this open source IP for HPC applications, and it also provides some reference workflows. And through the marketplace and integration, interoperability, the result can be a modular form factor. So this model is much more approachable from an economic standpoint from HPC or another player who's not as big as the big companies that we showed before. So call to action, let's support this effort. It's very promising, not just for HPC, but for other communities that want performance improvements from specialization, but cannot do that just by themselves. And we also could use some help with identifying which kernels we should invest on, which HPC kernels and other compute kernels in other communities we should invest on to design specialized hardware for. And we can also, of course, work on some methods to integrate that in a system gracefully. Talk about job scheduling, talk about programmability, APIs, runtimes, and so on. So I think that's it. Thanks for your attention.